Hello everyone. So today we are going to discuss a problem that is related to finding how many different parts. So specifically the problem is if there is a flea going between 2 points which are 100 inches apart. For example, it could be from point X to Y and they are 100 inches apart, and flea is going to jump either 1 inch or 2 inches at a time, as you can see in this picture. So the question is, how many different paths can the flea travel by? So first, let AN denotes the number of different paths that a flea could travel by if the total number of distance is n inches. So if after defining the variable, so our goal is then to find 100. It means when n equal 100. For example, consider, so for in order to, next goal is to find an expression for an. So we could write an as an minus 1 plus an minus 2. So first consider about the last step. It means we are at y, and then consider that we are all possible number of options are, if we are at y and we look back just one step, for example 1 inch distance. So here n equal 100, this step is n minus 1. So if it is only 1 inch is left, if we are at 1 inch before the last step, if we are here, there's only 1 inch remaining, and number of possible paths to come up to n minus 1 distance is going to be a n minus 1, and after that there's only 1, because there's only 1 inch, there's no choice. So if it is, so that is why we put it here in this way, n minus 1. On the other hand, if we are at the last stage, we consider all the last step, and like 2 inch back, here would be like n minus 2. And if we are here, how many possible number of ways we have? So there are n minus, that is where we put this an minus 2. There are total of an minus 2 number of paths, and after that we could skip to last stage. So since flea can jump either 1 inch or 2 inches at a time, it could have made the last jump either from the end of n minus first inch or from the end of the n minus second inch. That is why we consider these two options. So hence the total number of ways the flea can cover the distance of n inches is jumping either 1 inch or 2 inches at a time, and it is the sum of the number of ways the flea can cover the distance of n minus 1 inches, jumping either 1 inch or 2 inches at a time, and the number of ways the flea can cover the distance of n minus 2 inches, jumping either 1 inch or 2 inches at a time. So it should be the sum of these two terms when it comes to finding number of paths to travel in distance. So in other words, we could say that if n is greater than 2, we have this number of ways to travel the distance. If n equal 1, it means total distance is from x to y is 1 each. Number of ways, number of ways that we could travel is just 1, because there's only 1 each. It could travel it by just 1 each step. Whereas if n is equal to 2, a2 is, let's see, so now the distance is total distance. Here n equal 1 is 2. How many number of ways? Yes, if we can travel by 1 inch at a time, because when it travel 1 inch, there's only another 1 inch remaining, and obviously it could travel it using 1 inch. So it is a one way. And or else it could travel using a single step of size of 2 inch. So it is another way. So total number of paths are 2. So a2 is 2. So note that this is the recurrence relation for Fibonacci sequence. So now, keeping that, so let phi 1 equal to 1 over root 5 over 2 and phi 2 equal to 1 minus root 5 over 2 be the roots of characteristic equation of this one, x squared minus x minus 1 equal to 0. So an is going to be c1 phi 1n plus c2 phi 2n for all n that is greater than or equal to 1. So the constants c1 and c2 are such that a1 equal 1 and a2 equal 2. So next is to solve the linear system. So when a1 equal 1, we can write a1 equal, we could write c1 phi 1 plus c2 phi 2 equal 1. From a2, c1 phi 1 squared plus c2 phi 2 squared equals 2. So by solving this system, we obtain solution for c1 and c2 as 1 plus root 5 over 2 into root 5. So that is phi 1 over root 5. So c2 is then and it is phi 2 over square root 5. So therefore, since now we know c1 and c2, so by substituting it to this equation, we can find an as 1 over root 5 so this is a common expression for for number of possible paths for n distance, but our goal is to find 100 when there's 100 inches, when it is 100 inches apart. So what we're going to do is we're going to substitute n equal 100 to this equation, and we find 100 tells us 5201. So this is the final answer for number of possible paths to travel 100 inches distance if a flea could travel in this way, like 1 inch at a time or like 2 inch at a time. So this is the end of the video. I hope you learned something, and thank you so much for listening.